I'm Diane Margaret Bumanlag, and today I'll be doing something interesting with you, which is to verify the first law of thermodynamics. But before we dive into the experiment and know more about the concept of first law, we need to understand what is thermodynamics. So, thermodynamics, as the name suggests, is about thermal and dynamic properties. It relates to the temperature, work, heat, and energy, so it helps to convert one energy from one form to another. Now, what is the first law of thermodynamics? Thermodynamics. The first law of thermodynamics says that energy cannot be created nor destroyed, which means energy is indestructible. You can only change it from one form to another, but you cannot destroy it. That is why it is also called as the law of conservation of energy. So, to know more about the first law of thermodynamics, we were going to be doing or we were going to conduct a very simple experiment, probably a simple one that we can even see in our daily life or in our daily lives or daily application of life. So, what is science without any fun experiment, right? Fun fact: popping a popcorn can be considered a science experiment because it involves several scientific principles. Additionally, the process of popping involves thermal conductivity, where heat is transferred from the stovetop to the popcorn kernels. This can also be interpreted as an example of heat transfer. Furthermore, the conditions required for successful popping, such as used, the amount of oil used, the temperature, and the size and shape of the kernels, make it a scientific experiment with variables that can be tested and adjusted for optimal results. So that's why today we're gonna make some popcorns while learning about first law of thermodynamics. Here we are with all of the things that we need to use in our experiment. So here is the pot that we are going to use later, and this is the uh, corn or kernels that we will use, and this is the oil that we are going to use that you can see from there, but I will show you later. And there's the induction cooker in our kitchen that you will also see later because I can't get it here.
To start the experiment, we need to of course plug in the induction cooker and make sure to turn it on only for medium heat. Here we are with all of the things we need to set up for the experiment. Firstly, we need some oil or you can use butter. Next is the popcorn kernels. We also need an induction cooker, and for the last equipment, we need a pot with a lid, and these are the items that we need for our experiment. Now let's just wait for the pot to be heated before we put some oil. Next, if the pot is already hot, pour some oil onto the base of the pot and make sure the oil covers completely the entire bottom of the pot. Let's wait for the oil to reach the temperature that we needed or to be hot before placing the popcorn. And now it's ready, so we're going to place the popcorn into the pan or pot that we're using. Make sure that they are completely flat and even, so I'm going to use a spoon to spread it evenly. We will now wait for a few minutes until thermal equilibrium is reached and temperature is constant. Make sure that the lid or cover of the pot is completely covered as well. For now, let's just wait and observe the changes that's happening to the popcorn. So right now, you can see that the oil is already starting to boil and the steam is filling up the pot. You can see our first corn pops, and let's just have fun watching this satisfying moment of making popcorn. After it's done popping, turn off the induction cooker and remove it from its socket. After it's done popping, gently lift the lid of the pot, and after it you can place it in a clean bowl. We can see how much volume of the popcorn kernels have changed, how large they have gotten also. So now we're ready to eat.
So now you will see how much volume of the popcorn kernels have changed, how large they have gotten. So here's the popcorn kernel a while ago when it's not heated, and this is now the size of the popcorn kernel when it's heated in the pot. Look how it gotten so much bigger than the original popcorn kernel. So it increased size. It become bigger than the previous one. It's time for some popcorn discussion. So have you ever wondered why the popcorns burst like this a while ago? From little tiny, from this little teeny tiny seeds here. So how amazing it is that something we often face in our daily life that we often overlook is related to thermodynamics. So what do you think the reason would it be? It is for surely it's related to the kernel inside the popcorn. So let's take a deeper look at this again. So as you can see in the picture above, that a popcorn kernel is made up of several components. So it is mainly made of soft starch surrounded by hard shells, and this soft starch contains about 11 of water, which is trapped inside of it. So for the second picture here we can see what will happen to the popcorn when heat is given when we put the popcorn kernel on a heated hot pan. What happens is that the starch and the starch that contains water begins to heat up. So when the temperature exceeds beyond 100 degrees Celsius, because 100 degrees Celsius is the boiling of point of water, right? So when this temperature exceeds beyond 100 degrees Celsius, the water that is inside the popcorn kernel undergoes a change of phase, which means it changes from liquid to gaseous state, or we can call it as steam. We have to remember one important thing, which is the popcorn kernel. So the popcorn kernel now has a very thick outer shell, so it gives kind of a constant volume to it. So the steam is actually building up inside the shell. Another thing is that when the temperature is constantly rising in a close or constant volume, the pressure is also constantly building up. So at one point, this internal pressure catastrophically bursts, and this releases the starch-like gel-like structure to burst open into what we call as popcorn. Now, let's explain this a bit thermodynamically. In this experiment, the system would be the popcorn kernel, whereas the surrounding would be the pot with the lid, the kitchen, and the entire universe. So in short, our system of popcorn kernel is actually a closed system which undergoes some chemical reaction. So let me explain the first law of thermodynamics applies that the energy into the system is equal to the energy out of the system together with the change in energy of the system. So in our popcorn experiment, we had assumed that the popcorn in the system and the pot is the surrounding. Thus, the energy from the induction cooker is coming into the popcorn. The change in the temperature of the popcorn signifies the change in energy of the system. So we had assumed that the system would only be the popcorn. However, the true system have here is the part of the induction cooker as well as the popcorns. This is because the energy given out by the induction is not only given to the popcorns but also to the air inside the pot. There's multiple energy conversion that's happening inside the pot, and the most prominent one is the steam, because as soon as the popcorn bursts open or burst, the steam is released inside the closed pot. So this sudden mass transition from liquid to steam also cools the kernel, which is why it does not burn immediately after popping. The starch within the hard shell of the kernel also plays its role. As the steam inside the kernel breaks through the shell, the starch inside the kernel does not actually explode. Instead, these gelatinized starch granules expand into thin jelly-like bubbles. Neighboring bubbles fuse together and solidify, forming a three-dimensional network much like a sink full of soap suds. This then cools to become the white, fluffy solid we eat. Errors in the production process will also have an effect on the end of product. It is necessary to have maximal distribution of heat throughout the corn before the explosion. If the heat is too low, the steam can leak out slowly, resulting in a less light kernel. If the heat is too high or is unevenly distributed, only a portion of the kernel will be hot enough to pop, resulting in a partially popped kernel. That's it for today's video of the topic thermodynamics, and I have tackled the first law of thermodynamics, and I explained it through this video, as well as I've shown you my experiment of the popcorns. I hope you had so much fun in this experiment while I'm making popcorns, as well as learning about thermodynamics and the first law. So that's all. Thank you for listening. Bye.